Hello everyone, this is aaghaazkhan and this is my submission for Google Tunix hack. My submission is about self-corrective reasoning via structured reinforcement learning. So the core challenge of my submission is we are not going to use any human chain of thought and no LLM judges. That means this project shapes reasoning through structured proxy rewards, which helps us maintain the computational efficiency. So, introducing CURE, a reasoning protocol. This makes the model make their first initial reasoning and then critique its own reasoning, finding for flaws or issues in its reasoning, and then it gets a chance to correct itself. That means the model corrects itself and refines its reasoning and then gives us a final updated reasoning. Then according to that final reasoning, it gives us the final answer. I've trained the model on 4 different sessions, from which session 1 contains math reasoning. This session focuses on both the model reasoning for solving the problem as well as the accuracy of the final answer. Going through the reward functions, we check the formatting of the model, which must include reasoning inside reasoning tags and answer inside answer tag. So we give the reward from matching format exactly as well as matching format partially. Apart from that, we check answer format and we check the answer of the model comparing to ground truth answer. We give reward for both matching partially answer as well as matching exactly. For partially, we give model rewards on the basis of the ratio on how close it is to the ground truth answer. After that, we have CURE specific reward functions. So in CURE, we have 3 markers, which are initial reasoning, critique, and final reasoning. So in this reward function, we basically check the section presence of the CURE markers and give the rewards according to that. Coming to session 2, this session is based on training the model for general reasoning. So this task is basically non-verifiable and it doesn't have any ground truth answer. So we just focus on improving the model's reasoning, which will lead us to a final good answer, basically a final good general reasoning. Coming to the reward function of this session, it actually is pretty close to what we have done earlier. And we are checking again the format just as earlier. We'll just be checking the structure format in this particular session if the model is maintaining the structure. In the third session, I've trained the model on science reasoning. So basically, I'm using a private dataset which consists of science problems, and the model is going to provide a reasoning on that and then provide a final answer. Again, we have the same format checking reward functions. And then we have answer correctness function, which basically checks answer with the ground truth answer, and we give a penalty and reward points according to that. If the answer is wrong, we provide the model minus 0.5 penalty. And then we have our Q sections just as earlier. Coming to the last session of this model, we'll be training the model on Python coding problems. The reason I just chose to train on Python coding problems is I've already specified earlier that I'll not be using any LLM judges or any tools. So that means I cannot verify the code of other languages. Coming to the reward functions, again we have the same reward functions for matching the format as earlier. And then over here we are extracting the code from answer. We'll be removing the Python fences if the model outputs it. After this, we'll be executing the code using the exec function. Then we will be providing the rewards according to the code, and I'll also be providing some reward points if the model's code is executable but has wrong answer. So that's all about my submission. Thank you.